Hello guys! Thank you for once again visiting to my channel. I hope I have helped you. And this time, just relax. Enjoy learning easy mathematics with me. Okay, see what we have here. So this time we are up to factoring difference of two squares. Now before we go any farther, let me first show you an illustration or a demonstration related to our lesson. So we have here, let's consider the square figure below. What is the area of the figure if its side is x unit? Let us see. The side of this square figure is x unit. Now, we know that the area of any rectangular figure, and in this case, a square figure, is equal to the product of its side. And since this is a square figure, we can simply say that the area of a square is equal to the square of the measure of its side, or the measure of its side square. The area now is equal to the product of x and itself, which gives us the square of x, or the area of this square figure is equal to x squared. Now take note that the unit of measure of area is a square unit. Same figure is cut by a smaller figure by y unit. Now let's look at here. Okay, so again, a smaller square with y unit is cut along this corner. And what is the area of the smaller square that is cut? So we have again, area is equal to the square of its side. And its side is y. So therefore, we have here the area is the square of y, or y squared. And what is the area of the remaining part of the figure? To find the area of the remaining part of the figure, let me trace this part of the remaining figure. And as we can see, another figure is formed. We have here a rectangular plane figure. The property of a rectangle says that the opposite side of a rectangle is equal, so we can write here y. Okay, so this measures also y unit. How do we get this expression? Take note that this side here originally measures x unit. Okay, this is x unit. But earlier, we cut a smaller figure, square, with y as the measure of its side. Now, in a mathematical expression, cut is translated as subtraction. That's why we have here, we subtract y from x, or we have this expression x minus y. Similarly on this part, and y is cut from here, so we have here the expression x minus y. We will separate that figure, label each part. Earlier, the property of a triangle says that the opposite sides of a rectangle is equal. Now in here, we will do some simple manipulation. Okay, so we join this part here to the remaining part of this figure, or the bigger rectangular figure. So what we have formed is larger
rectangular plane figure. Now, we have already explained this one earlier. So, we have this, okay, and this y here. And how do we get x plus y? This side here is x, and this side here is y. Take note of the term and. And in mathematics means addition. That's why we have here x plus y. Okay? So, the area again is equal to the side or the product of the two sides of a rectangular figure. And that is equal to, okay, x plus y multiplied by the difference of x and y, or x minus y. So the area now can be expressed as the difference of two squares. If you can still remember, this is a special product, and we call this as sum and difference of two terms. And the product of this special product is called the difference of two squares. Okay? And for our main discussion, we have, okay, so, and by substitution, we can write these two equations as one. So we have the factor of the difference of two squares is the product of the sum and difference of two terms. So let's proceed to our example number 1. Factor the following binomials. So in this case, we have here a squared minus b squared. Okay? Now, in this first term, our base is a, and the second term, our base is b. So what we will do is we simply copy the two bases and we write the operation addition, and we do the same here with subtraction operation. So therefore, the factor of a squared minus b squared is equal to the product of a plus b and a minus b, which is actually the sum and difference of two the same terms, and these terms is taken from the bases of the two terms here. So we can write the product of a minus b and a plus b, and that is because of commutative property of multiplication. And for our next example, we have here m squared minus 16. Take note, we need to express each term in a square form. M squared here is already in a square form, but 16 is not yet in a square form. So we express each term in a square form first for easier factoring. So we have here now the square of m and the square of 4. Why 4? Because when you multiply 4 by itself, the product is 16. Okay? So, here, our base is m, and our here base is 4. So, what we do is simply copy the bases, and we write the operation, doing the same on the other factor with subtraction operation. Or, in our next example, we have here 25x squared minus 4y raised to the power of 6. Again, take note to express each term in a square form. Now, this is not yet expressed in a square form. So, what we do is, okay, we have here the square of 5x. 5 because when you multiply 5 by itself, the product is 25. 2 because when you multiply 2 by itself, the product is 4. Now, how did we get 3? Okay, how did we get 3 here? So, 6 here is divided by 2. and the quotient is 3. And we enclose these terms and raise to the power of 2. So our bases now are 5x and 2y cubed. So to factor, we just simply copy the bases and the operation, doing the same on the other factor. Or for our example number 2, we are going to factor the binomial negative x squared plus 49. Now, first we have to rewrite this expression as the difference of two squares. Okay? So, instead of writing negative x squared plus 49, we can write 49 minus x squared. Okay? That is commutative property of addition. So then again, write each term in a square form. By the way, there's no an and here. It's only square form. So, 49 can be written in a square form as 7 squared. And of course, minus x squared. So the factor, for the factors, we have here 7 plus x multiplied by 7 minus x. Okay. Now for our example number 3, we have factor the binomial m squared n raised to the power of 6 minus y raised to 4 z squared. Okay, again, write each term in a square form for us to easily factor the binomials. Let's look at here m squared. So we divide 2 by 2. The quotient is 1, so we can simply write that as the square of m. In another factor, n raised to the power of 6, we divide 6 by 2. And the quotient is 3. So we write n cubed and raise it to the power of 2. Okay, copy, subtraction. And for y raised to the power of 4, 4 divided by 2 is y squared now. So raised to the power of 2. And of course, z squared is the square of z. Now, let's look at here. The same, these two factors here are raised to the same exponent, which is 2. So, we can write this, the bases, as one product. So, the same here. So, instead of this expression, we can simply write the square of m n cubed minus the square of y squared z. So we multiply the bases and enclose the product to the power of 2. So to proceed in factoring, our new bases now are mn cubed and y squared z. So of course, we simply copy. Okay, so we have this expression or factors. Now I think you are now ready for our exercises. So let's see. Okay, so you have your exercises A and exercises B. I think that's all.